Geometry homework section 16.3. Find the ratio of the trig functions indicated. Do not find the actual measure of the angle. So a little warning, these problems that you see here, 1 through 8, you have to be real careful that you don't directly apply what we just learned in this last note section. I know that sounds ridiculous, but we focused heavily on every picture that we drew was in the coordinate plane, x and y axis. In a coordinate plane, the opposite leg is always y, the adjacent leg is always x, and the hypotenuse is always r. Therefore, in the coordinate plane, sine of an angle is y over r every time. Cosine is x over r, and tangent is y over x. But questions 1 through 8 are not in the coordinate plane, so you can't use things like x, y, and r. We need to use opposite leg, adjacent leg, and hypotenuse. Number 1, tangent of theta. Tangent is the opposite leg over the adjacent leg, so this is 3 over 4. Number 2, sine of theta is the opposite leg over hypotenuse, so that's 6 over 10. You do not need to reduce your fractions for this. Number 3, cosine of theta is the adjacent leg over hypotenuse, so that's 3 square roots of 21 over 15. Number 4, tangent is the opposite leg over the adjacent leg, so that is equal to 6 over 8. Number 5, sine of theta is the opposite leg over the hypotenuse, so that is square root of 15 over 16. Number 6, cosine of theta is the adjacent leg over the hypotenuse. No need to rationalize your denominator. We're just looking for you knowing what these ratios are. Tangent of theta is opposite leg over adjacent leg. That's 4 over 2 square roots of 21. And finally, sine of theta is opposite leg over hypotenuse. So that is 12 over 20. In each case, you start with the angle that you are referring to. Now, question 9 through 14, this is coordinate plane stuff. So that means when we're looking at question number 9, sine of theta is y over r. So in order to do this problem, we have to know what x, y, and r are. We're going to make a reference triangle. So this is the hypotenuse. We're going to make a reference triangle which always includes the x-axis as one of the legs. X is negative 8. Y is negative 15. And we don't know what the hypotenuse, what r is. Or do we? This is the Pythagorean triple. And 8, 15, 17. If you didn't realize that, use the Pythagorean theorem and you can figure this out. So the angle that we use, even though this is the angle theta, you always use the reference angle, and that reference angle is called theta prime. It's not entirely 100% important that you know that right now, but cool if you did. So what is sine of theta prime? It is the y value over the r value. So that's negative 15 over 17. Done. Number 10, cosine of theta. So here's theta. We have, this is the hypotenuse of our triangle. We want to make a reference triangle. We want to make it with the x-axis. So we're going to drop a vertical down. X-axis has to be one of the legs. That would make this theta prime in here. X is negative 5. Y is square root of 11. Cosine of theta is x over r, adjacent leg over hypotenuse. We don't know what the hypotenuse is. This is not a special triangle. It's not a Pythagorean triple, I should say. So we're going to use Pythagorean theorem. X is negative 5. Y is square root of 11. Don't know what r is. It's going to be 25 plus 11 is r. It's 36 is r squared. So r is plus or minus 6. The radius is always positive. It doesn't matter where this falls. Therefore, cosine of theta is negative 5 over 6, x over r. 11 through 14, draw the reference triangle. Find the exact value of the trig ratio. These are the same questions that 9 and 10 were, but 9 and 10 started giving you a picture. This one doesn't give you a picture. 6a is going to fall in quadrant 1. You don't have to draw this to scale, but make sure it's in quadrant 1. So that's saying that we're going to go to the right 6. We're going to go up 8. So that gives us this triangle here. X is 6, y is 8. We don't know what r is. Or do we? This is a Pythagorean triple. 6, 8, 10, which is double a 3, 4, 5. If you didn't realize that, use the Pythagorean theorem and you would find that it's plus or minus 10. Radius is always positive. Sine of theta is always y over r in a coordinate plane, so that's 8 over 10. No need to reduce your fraction. 12 cosine of theta is square root of 3, negative 1. That's going to be in quadrant 4. So we go to the right, square root of 3, then we go down 1. Every time, on this previous picture, I should have put a theta in here. Every time we do this, we need to make sure that our right triangle, that the x-axis is one of the legs. The angle we're using is a reference angle. It's formed by the terminal side in the x-axis and it's acute. Now, you can use the Pythagorean theorem for this, or you might recognize this is a special right triangle. And I mean special, I don't mean Pythagorean triple. This is a 30, 60, 90. Opposite 30 is 1. The long leg is that times the square root of 3. The hypotenuse is the short leg doubled. Hypotenuse is always positive. This is a special 30, 60, 90. If you're thinking, I didn't realize that and I still don't realize it, that's cool. Use the Pythagorean theorem and you're going to find that it ends up being 2. X is negative 1. Y is square root of 3. Don't know what r is. You're going to get r is plus or minus 2, but the radius is always positive. Cosine of theta is x over r, adjacent leg over hypotenuse. So that's square root of 3 over 2. Moving on, number 13. Tangent of theta for negative 15, negative 5. Negative 15, negative 5 is in quadrant 3. So we got our reference triangle. X is negative 15, y is negative 5. We don't know what r is, but guess what? We don't have to know what it is because tangent of theta is y over x. Y is negative 5 and x is negative 15. You can reduce that if you want and make it positive 5 over 15. Wouldn't necessarily have to. Number 14, negative 2 square roots of 3 is in quadrant 2. Make a reference triangle. Reference triangle always uses the x-axis as one of the legs. So we got negative 2 and we got 2 square roots of 3. We don't know what r is. This is not a special right triangle. Well, actually it is, but it's not as easy to distinguish. So let's just use the Pythagorean theorem. We got x squared plus y squared is r squared. And we have to know what r is because sine of theta is y over r. We know what y is. It's 2 square roots of 3. We don't know what r is. So x is negative 2. We have to square that. Y is 2 square roots of 3. We have to square that. We don't know what r is. And negative 2 squared is 4. If you square 2, you're going to get 4. If you square the square root of 3, you're going to get 3. So that's going to make that 4 times 3. So that's 4 plus 12 is r squared. So that makes r plus or minus 4. R is always positive. Turns out this is also a special right triangle. It's a 30, 60, 90. So this is 2 squared to 3 over 4. If you want to reduce that, you get square root of 3 over 2. Don't have to. 15 through 18. Draw the reference triangle. Find the exact value of the trig ratio for theta. This appears to be wildly different than the last problems we did. It isn't. It's the same. In each case, you are told, either explicitly, which we were in the last couple problems, or implicitly, like we are here, what two of the numbers x, y, and r are, and you got to find the third. All right, so we're in quadrant 3. Let's start with that. I'm going to draw a picture of a reference triangle in quadrant 3. This reference triangle, as I mentioned more times than you want to hear, has to use the x-axis as one of the legs. Has to. So this is theta. Then, if you look at what it's saying tangent is, tangent of theta is 12 over 5. What letters do we associate with tangent? Y over x. Here's why this appears to contradict itself. If y is 12 and x is 5, that has to be in quadrant 1. So how could it be in quadrant 3 and this be true? Did I make a mistake? I did not. If both of these are negative, the negatives would cancel out and make a positive. So this is actually a negative 12 over a negative 5. So y is negative 12, x is negative 5. We got to figure out what r is, because we're supposed to figure out what sine of theta is, and sine of theta is y over r. You can use Pythagorean theorem to figure this out, or if you know your Pythagorean triples, this is a 5, 12, 13 Pythagorean triple, which makes this negative 12 over 13. 16. Oh, this one's using radians. Lovely. Pi over 2 is the same as 90 degrees. Pi is the same as 180. So we are saying this has to be in quadrant 2. Let me draw this. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. Makes a complete revolution. So we know that we're in quadrant 2 because it says that we're falling between pi over 2 and pi. So that's got to be in here someplace. And then this says cosine of theta is negative 4/5. Now let's forget about the negative just for a moment. Cosine is x over r. We got to put this negative sign someplace. Do we put it with the 4 or do we put it with the 5? So there's two reasons why we'd put it with the 4. One, we're in quadrant 2, which means we have to go left. So x has to be negative. 2, we can't put it with a 5 because I've told you the radius is always positive. Now we just got to figure out what y is. This is a Pythagorean triple. It's a 3, 4, 5 right triangle. If you didn't know that, use the Pythagorean theorem and you'd figure out that that was 3. The question is for tangent of theta, that's y over x, which is 3 over negative 4. 17, given that tangent of theta is negative 15/8, where sine of theta is less than 0, find cosine of theta. All right, so this is telling us that y is less than 0. And when does this happen? This happens in quadrants 3 and 4, where the y value is negative. Because sine of theta is y over r. R is always positive. So y would have to be negative. That has to be in quadrants 3 or 4. Tangent of theta is negative 15/8. Let's examine that for a second. That's either negative 15 over 8 or it's 15 over negative 8. It's got to be one of the two. Remember that tangent is y over x. So which of these cases has y being negative? This first one here, negative 15 over 8. So this one doesn't work. That tells us we have to be in quadrant 3. I'm sorry, tells us we have to be in quadrant 4. We have to be in quadrant 4 because x is positive and y is negative. So we draw a reference triangle in quadrant 4. X is 8, y is negative 15, r is 17. This is a Pythagorean triple. I intentionally made all these Pythagorean triples, not all of them, but many of them, to reward those of you that have taken the time to learn them. If you didn't know a Pythagorean triple, use the Pythagorean theorem. So to answer the question, what is cosine of theta? It is x over r, which is 8 over 17. 18. Cosine of theta is negative square root of 5 over 3. Well, let's examine that first. Cosine of theta. Where does the negative go? Does it go on top or does it go on bottom? Well, it has to go on top because cosine is x over r. R is always positive, so that has to be negative. This says tangent is negative. Well, tangent of theta is y over x. And since we know x has to be negative, and we divide this and we have to get a positive or we have to get a negative answer, we know the top has to be positive. If they were both negative, you would divide it and get a positive answer. But since tangent's negative, that tells us we have to be in a place where y is positive and x is negative. That's in quadrant 2. So, since we know x is negative square root of 5, and we know r is 3, we just got to figure out what y is, and this is not special in any way. So we're going to use the Pythagorean theorem. X is negative square root of 5 squared. Don't know what y is. R is 3. We have to square that. A negative squared is positive. Square root of 5 times square root of 5 is 5. 3 squared is 9. Y squared is going to be 4. That's going to make y plus or minus 2. So what is y? Is it plus or is it minus 2? Well, it's positive 2 for a couple reasons. 1, we already established has to be positive. 2, we're going up. 3, we're in quadrant 2. Those are all reasons why it has to be positive. The question is, what if sine of theta? Sine is y over r. That's 2 over 3. All right, we're getting close. 2 more. Find the exact value of the other 2 trig functions of angle theta in standard position. So we're told 2 very important pieces of information here. 1, tangent of theta as a fraction is 3 over 1. Tangent is y over x. Now, both of these could be positive or they could both be negative. We're in quadrant 3. In quadrant 3, they are both negative. So it's a little misleading when you have tangent because your signs disappeared. So in quadrant 3, we got x is negative 1, y is negative 3, and we don't know what r is. To figure it out, we're going to use the Pythagorean theorem. X is negative 1, y is negative 3, and don't know what r is. Negative 1 squared is 1, 3 squared is 9, 1 plus 9 is 10, square root both sides, you get plus or minus the square root of 10 is r. R is always positive, so it's the square root of 10. Find the other trig functions. So sine of theta, which is y over r, cosine of theta is x over r, sine is negative 3 over the square root of 10. Go ahead and leave that with an irrational denominator. That's not our focus. Let's not add a ton of work to you folks. So these are our answers for 19. 20. Let's end with a Pythagorean triple, shall we? Sine of theta is 3/5. Sine is y over r. So y is 3 and r is 5. Quadrant 2, draw our reference triangle, label it y and r. X is going to have to be -4. This is a Pythagorean triple, a 3, 4, 5. The reason it's negative is we're going left. So what is cosine of theta? Well, it's x over r. What is tangent of theta? It is y over x. So this is going to be -4/5 for cosine and 3 over -4 for tangent.